Good day, pre-algebra. Today we'll be talking about slope. Slope is a recurring theme in pre-algebra and algebra. You'll hear the word slope so often, it'll start to sound weird. Slope. Slope. Okay. I understand you've done it before, so who can give me kind of a definition? What do you remember about slope? What do you remember about slope? Tony?
Distance from one line to another.
The distance, I'm gonna change that from line to point. Okay, the distance from one point to another point. I can see how that would be a working definition. Quentin, what do you remember? Rise over run. That's kind of a common phrase. We're gonna put that actually under the how slope is found. That's kind of that catchy phrase there. Rise over run. What else do you remember? Tony? Okay. I'm actually going to take Tony's original definition and tweak it slightly. The slope of a line is essentially how a line moves across the coordinate plane. Okay. How a line moves across the coordinate plane. Tony said to get from one point to the next. That's essentially what slope tells you. Okay, it's like MapQuest. How do you get from point A to point B? Okay. And if you're like, who still uses MapQuest? I still use MapQuest. Okay. How a line moves across the coordinate plane. And this phrase, rise over run, what does that mean? It's catchy. It's alliterative. What does it mean, John?
Like rise being like how far the point is, and run being like the x. So
yeah. So the rise, essentially what this means is the change in y, right? Because the y's are vertical axis. That's the up and the down. The change in y over the change in x, that horizontal change along the x-axis. And we shorten that to be rise over run. How far does our line go up or down? And how far does it run over? Okay? I think that's a pretty good definition for now. We'll kind of expand on it in future objectives, but this is going to get us through CO50 just fine. Okay? Questions on this before we go down? All right, let's do some practice. Okay. I don't put the lines for you because I do want you to practice plotting points also. So it says plot the two given ordered pairs and connect them with a line as straight as you can. Then find the slope, show the change in y and the change in x. So the first one, -4, 2. Your point's going to go right there. -4 on x, 2 on y. And your second point, -3, 5. Going to go there. Okay. And before I put my line in, we're actually going to find the slope because we don't want this to get too cluttered. Okay? But going off that definition of change in y over change in x, I mentioned slope being kind of like the directions. How would you describe how to get from that first point to the next one? The point on the left to the point on the right. Shane? Go up. How far?
To the next 3.
Okay. But how far do you go up? Do you go up 10? Do you go up 1? How far do you go up?
You go from one point to the next.
So you're saying just go there. Okay. I don't know how successful I would be if MapQuest just said just go there. Right? I need more direction. Kylie.
Over 1, up 3.
Okay. So we're going over 1 and up 3. I'm gonna change that. The order is important here. Since slope is change in y over change in x, or rise over run, we want that change in y written first. So Kylie's saying we're going up 3 and over 1. Right? That would be the slope. The rise over run equals 3 over 1. Okay? Up 3 over 1. Yes?
Do I start from the lowest one?
You start with the point on the left. Sometimes it'll be the lowest one, sometimes it'll be the highest one, but you start with the point on the left. Okay? That's a good question. Tony?
So like, say if you're going down, is it like negative?
It will be, yeah. Now that we've got the slope, we can put our line in here, connect those as straight as you can, okay? And the reason why this is important is because, the slope of this line, it doesn't change, right? If we pick this point down here and add a dot, notice how we get from this point up to the next one, up 3/1. It's kind of like a staircase. Certainly you've gone downstairs before where they're not all the same size, and how awkward that is to like adjust your footsteps as you go downstairs. We want things to be the same, and that's what slope is here. Okay? The next one, 1, 6, and 5, 3. 1, 6, that's going to be up here. 5, 3 is right here. Starting with the point on the left, tell me how we get to that point on the right. Give me directions. Abby. Down 3/4, right? Down 3/4. So how would we write the slope of this then? How would we write the slope of this? Griffin.
3/4.
Yep, and Tony said earlier, if it's going down, does that mean it's negative? Yes. Okay, down 3/4. Negative 3/4. Okay, negative 3/4. And like we saw, like I kind of pointed out in the last objective, notice how when our slope is positive, like it was in the first one here, our line is going up from left to right.
Yeah.
And then when it's negative, it's going down from left to right. Okay? So whenever you see a slope that's going up from left to right, you know it's going to be positive. And then a line going down from left to right, you know it's going to be negative. Another one on this page that you want to do. I think there are only 6 of them, so I don't want to do all of them for you. There's no fun in that. Is there one that people have come across that you want to talk about? Carter? The last one. Why not? 0, 5, and 6, -3. 0, 5 here, 6, -3 here. Give me directions. Going from left to right. How do I get from one point to the next? John.
Like you could count every square unit that there is and cross and up.
Yes, except we're not going across and up, right? Because if we went across and up, that would mean that we're going from right to left. We want to go from left to right, so we'll be going down and over, right?
Yeah.
But yeah, you can just count the squares. What do you come up with? Sophie.
Down 8 and then over 6.
Down 8 over 6, right? This is down 8 over 6, so our slope is going to be -8 over 6.
-8,
8, 6. Now here's the cool thing about slope, and some of you might already know this, okay? This is a fraction, right? -8 6. What does -8 6 simplify to be? If we're in simplest form.
You're serious right now?
I am being serious. Quite serious. Abby. -4/3. Watch what happens if from my original point, that top point, that left point, instead of going down 8 over 6, I go down 4 over 3. So I'll do that in blue here. Okay? So 1, 2, 3, 4. 1, 2, 3. What do you notice about that
The same
point?
thing,
Same thing.
but smaller.
It's on the line, right? It's on the line. Going down 4 over 3 puts us on the same line as going down 8 over 6 does. And if I go down 4 over 3 again from this point, 1, 2, 3, 4, 1, 2, 3. Back to the green point there. Okay? So equivalent fractions come up big when we're talking about slope, which means that when you write slope, you should put it in simplest form. The slope is -8 6, but your final answer should be -4/3. Okay, because that's simplest form, and it puts us right back on the line. Quentin, your hand was up earlier.
Can you go up and over?
You can you go up and over? Yes, if it makes more sense to you to do that. you can, as long as your change in y is in the numerator of your slope and the change in x is in the denominator, then you'll be fine. Okay? But because we read graphs from left to right, it's like you read the page of a book. Could you read the words backwards and then kind of make something head? Sure, you could, right? But since we read the graph from left to right, typically we would go down and over versus up and over. You don't want to go over and down, because if you go over and down, then the temptation is to put that x change in your numerator, right? Like if you're going over and down, you'd say, I go over 6 and down -8. Well, look what you just did. You wrote your slope backwards, right? Okay? Because people will read this not as over and down, they'll read it as up and over, which is how it should be read. So if you go over and down, it's a big danger of running your slope upside down, which you don't want to do. So definitely not recommend doing that. Yeah.
So what would happen to your denominator if you were to go left instead of right? Would it then become negative?
Yes, it would.
Okay.
Yep. And so Jack's asking if you did go up and over, you would get a slope of up 8 and over -6 because you're going left. The reason why this isn't wrong is because these two values are the same. A -8 divided by +6 is the same thing as a +8 divided by -6. Right? So that's why it works out to be the same. But, in your head, it's just kind of, yeah.
No, I was wondering, say the plot was a positive or -6 and you had to go that way, would then your answer be able to be -6 or -8 over -6?
It wouldn't be -8 or -6. -8 over -6 would be going down and left.
Yeah, but if it was -6 and -3.
Can you draw what you mean? Not on your page. Yeah. Okay. Just ignore these points and draw what you mean on this corner plane so I can take a look. That'd be easier. Those of you that are working, this will be homework for tomorrow. We'll talk about the bottom three in just a little bit, but this will be homework.
All right, that's like okay. So on the old one, we went like that. But what if our other point was there,
Yeah.
and then we came
Down and over. Yeah.
that way?
So going down and over would give you a -8 over -6. However, going from left to right, you're going up 8 and over 6. And up 8 over 6 is the same thing as going down 8 and left 6, because a negative divided by a negative is a positive. So basically, you can go whatever direction you want as long as your y change is up top. I prefer you all stay consistent with it, because when I'm doing it up on the board, if we're all doing the same way, then we can answer questions about it better. However, if a different way makes more sense to you, as long as you get the correct answer, I don't really care. But if I teach it too many different ways, then people start to confuse the methods in their head, and then it just gets bad. So yeah.
So do we have to simplify the algebra?
Yes, you should simplify slope. Simplify. The three on the bottom, it says you are designing a water slide. Which slope above would be best? Okay, so now you gotta get to analyze. I think it was Blake the other day asked, when will we ever use this, right? If you're designing a water slide, you're gonna want to kind of map it out first before you just start building it, right? Yeah. Okay. And so as you're looking at these different options here, would a slope such as this make a very good water slide? Well, it depends on what you're into, right?
Yeah.
Would a slope like this make a good water slide?
Yeah.
Probably better, versus the last one, or the next one, wheelchair ramp. You probably want to go with one like that, right?
No, I go with the second one.
So, those bottom three, you are looking at the slopes from up above and deciding which slope would be best for each situation. Yes, Tony?
So we just look at, do we just write down the points?
Write down the slope.
Not like negative, not like.
Right, write down the slope.
Oh, the slope.
The slope. The slope that you find. Jeffrey?
I think you guys are being a bit unsafe here. If you look at the slope you picked for the water slide, let's say you're going down in your tube, you're going straight down. What if you hit a bump or something? You're going
Straight
head
down
first.
would be like that.
Look how slanted that is, though. If you lean forward, you're just gonna flip. I say number 2 up there.
Well, hey, you can argue that by all means, right? It's your.
Are we gonna
Water
get
slide.
points off then?
I'll choose
No.
number
Okay.
3 for the wheelchair.
As long as you can defend your answer, I'm okay with that. All right, homework tomorrow. If you did not finish the packet thing, I'll expect that tomorrow as well. That's my math.
Don't
forget
forget.
to like, subscribe.